Hello. Welcome to the final online event of the Climate Detective School Project 2018-2019. I'm Alana Bartolini from the ESA Education Office, and with me is ESA scientist Grete Straume. Shortly, we will hear more about her work and how she joined ESA. We are here at the European Space Research and Technology Centre in the Netherlands. This is the largest centre of the European Space Agency, and it is here that most ESA projects are born. Today is a very special day. We celebrate the completion of the Climate Detective School Project 2018-2019. We are joined live by more than 350 students from 30 teams. If you're watching live, go to www.menti.com and use the code 577273 to ask your questions to Grete. My colleague Fatima Pinto will moderate your questions, and later we will answer some of them. Hello, Fatima.
Hello, I'm here with Paxi, our Easy Education mascot. Hello, everyone. We are looking forward to receive your questions.
This was the first time that we ran the Climate Detectives project. In total, 118 teams from 16 ESA member states and Canada, which is a cooperating state, applied to this project. Before we show you some of the highlights of the first edition, I would like to introduce you to the ESA scientist Grete Straume. She has worked with the Aeolus wind mission, and she has also been involved in other Earth observation missions for ESA. Welcome, and thank you for being here.
Thank you very much for having me here, and I'm looking so much forward to see what exciting results that come out from the school projects today.
We're very excited to hear about the Aeolus mission and your work at ESA. But first, we'll show a short video to introduce the Aeolus mission to the teams.
What's the wind blowing? Perhaps blowing somewhere else. Over there maybe, or up there. Well, without the wind there would be neither weather nor a lot of other things. In ancient Greece, the god Aeolus caused the winds to blow across Europe. Later, the great seafarers took advantage of the strong trade winds to sail more quickly to the Caribbean. They also knew about the horse latitudes, the windless doldrums at the equator, and about the stiff westerlies in the North Atlantic that they used to sail back to Europe. Nowadays, aircraft use the jet stream around the pole to gain extra speed towards the east while avoiding them in the opposite direction. Wind is created when the heat of the sun causes the air in the tropics to rise and then move towards the poles. In between, the air moves in all directions due to warmer and colder spots and the uneven landscape. On top of this, the wind is also deflected by Earth's rotation. This is called the Coriolis force. This all leads to a constant intermingling of rising and falling drafts over cold, warm, flat and mountainous terrain, and is in effect the reason why the weather is so difficult to predict. Nowadays, meteorologists know quite a lot about wind in our atmosphere, about the invisible currents and streams pushing masses of air from here to there, from rising rapidly to descend again somewhere else. This is what gives us high and low pressure areas, tornadoes and storms. This is what brings us rain clouds and cloudless, at least in theory. Sometimes the wind is irresistible when flags flutter, when an aircraft wiggles, or when you can barely stand upright at top of a mountain. But wind is invisible, up to now. The European Space Agency ESA has built a satellite to measure winds from space in a new way. It'll help us understand winds better and make forecasts more accurate. Aeolus is the first research satellite that uses a laser to measure the wind all around the world. To do so, it sends a laser beam down into the atmosphere. The laser light hits the air molecules, ice crystals and dust particles in the atmosphere, and a small portion of it is reflected and captured by the satellite's telescope. This allows the movement of the air to be measured continuously and comprehensively from 30 kilometers altitude all the way down to the ground. There's never been anything like this. It's no easy task. It took hundreds of engineers and scientists nearly 20 years to develop this one-of-a-kind instrument, but now it's finished and launched into orbit. Its data will revolutionize our understanding of the wind, because our knowledge about the wind and how it changes is not very accurate. For example, the jet stream's key role in summer weather, or the polar currents and their influence on the climate and on the extent of the ozone hole in winter. The winds over the oceans aren't measured everywhere, and the world's 13,000 weather stations on dry land are distributed unevenly. By measuring the globe, Aeolus fills this gap. Not without reason that scientists around the world, weather reporters, climate wind turbine operators, shipping companies, aeroplane pilots, and countless other users are eagerly awaiting its first data.
So this was a great introduction. Could you tell us about your role in the mission?
Yes, so I'm a meteorologist. I have a PhD in meteorology, so that means that I have studied the atmosphere and how it works. And I've also been working with transport of air pollution, greenhouse gases, and other aspects that are important for the atmosphere. And since I've been working at ESA, I have indeed focused on this wind mission and the measurements of the wind. And my role is really to make sure that the scientists and the users get what they need, that they get the type of measurements that they need, and that they can use them for their research and for weather forecasting. So I'm running scientific activities, I'm supervising this and putting all this information together to make sure that we can get out of the mission what we need.
Okay, so we have here a picture which is showing some of the early data from the Aeolus mission. Could you explain to us what we're looking at here?
Yeah, so this picture is showing winds measured by Aeolus on a very windy day on the 10th of March this year. So it shows on this picture the satellite, how it's measuring from the North Atlantic, passing England and going all the way down to the tropics. And it measures the winds, as I said in the video before, from the ground up to 25 kilometers, which is shown here on the vertical. And the blue boxes over there, they're showing where the winds are very strong. So you can see the strong winds at the jet stream levels, which is about 10 kilometers in this picture. But in this day, the strong winds extended all the way down to the surface, giving very strong winds all over Western Europe and some problems for people who are working outside. So this is actually what we could capture with the satellite also on this day.
Wow. I have a prop here. I'm wondering if you can maybe show us how the satellite actually took this picture.
Sure. So here is a globe, and what the satellite does, it's flying from pole to pole like this, and as it is flying, the Earth is rotating under it beneath. So that means that the satellite can make measurements all around the globe. And on this particular day, the satellite was starting to measure here up close to the polar areas and going down towards the tropics, and then it can capture these very strong winds coming from the west into Europe and measure it.
Great, thanks very much for explaining that for us. So you joined ESA in 2004. Could you tell us about some of the other projects that you've been involved in?
So most of the time I've been working on the Aeolus mission, but I've also done some activities in support also, for instance, of the air quality missions and greenhouse gas missions coming. There is an example here on the screen of what is measured, for instance, with one of our Sentinel missions called Sentinel 5P, and it's measuring air pollution such as nitrogen dioxide, formaldehyde, sulfur dioxide, which gives rise to acid rain, for instance. It also measures ozone, so you could look at the ozone hole and its development, but also greenhouse gases such as methane and pollutants such as carbon monoxide.
Quite a lot of data.
Exactly. I've also been working on some future missions, for example, on one that's going to measure ozone, or missions that are going to look at the radiation and clouds in the atmosphere.
Great. Well, some of our climate detective teams are the young scientists of tomorrow. They're aged between 8 and 15 years old. Do you remember when you were that age, what were some of your interests?
So when I was that age, at least I knew that I liked mathematics and physics and chemistry in school. I grew up on the western part of Norway, and in this part you get all the weather coming in from the Atlantic, lots of rain and lots of wind. And I remember I was very fascinated by that, wondering how is the weather working? How can we make a good weather forecast? In this time period also, we had the discovery of the ozone hole, and there was also a lot of air pollution, and large international treaties to try and limit air pollution in Europe were coming up in the time when I was a child in the 70s and the 80s. So these were all topics that I found very interesting and very important at the time.
So then how did you decide that you wanted to go on and study meteorology? Can you tell us a bit about your university experience?
So I actually, when I was in school, didn't really know what I wanted to do, but I knew that I wanted to do something which had to do with physics and mathematics. So I started to study that at university. And as I was there, I saw the different types of studies being presented to the students, and meteorology was one of those that were presented, and they looked very exciting because then I could work with weather, but I could also work with climate and air pollution, and I found that fascinating. So that really made me choose that study.
And then what were your career steps after you finished your university degree before you came to join ESA?
So when I finished my university degree, I'd met my husband and he found a job in the Netherlands, and I decided, well, why not go abroad and have some experience there? So I came with him and started to work at the university here in the Netherlands. So I first started to work with a model which is modeling air pollution and greenhouse gases and how they change. Then I went on to work at the Meteorological Institute in the Netherlands, where I was looking at the effect of changes in the ozone levels up in the stratosphere. And after that, again, I went to the Dutch Space Research Organization, working with measurements of greenhouse gases from space.
Really
so quite
done a lot.
many different jobs before I started to work for ESA.
Okay, that's great. So speaking of working at ESA, what would you say is your most rewarding aspect of working here?
So besides working with really exciting novel technology projects, really new type of measurements are being made with our satellites, I also enjoy a lot the cooperation that we have. We have an enormous team across Europe of engineers, of scientists, and also inside of ESA and even beyond Europe, we have many researchers across the world who are working with our data and helping us to validate our data and make sure that our data are correct and as good as they can be. And this is fantastic to work with top-class specialists from across the world. That's very rewarding.
And do you have any suggestions for our students for their future careers?
So I would say if you like research and discovery, really go after these things. It's so important to have a job and work with things that you like to do and things that you're good in. And having a job that is well paid is really not the thing. It's to enjoy your work and to keep on discovering and to work with research is very rewarding. So I would encourage all the pupils to continue with that.
That's great. Thank you very much for your answers. Let's now see if the teams have any questions. So we'll turn over to Fatima. Fatima, do we have any curious teams today?
Yes, so far we have one question from one team. So don't forget, if you are watching live, go to www.menti.com and use the code 577273 to ask your question to Anna Grete. So far the question that we have is about El Nino. So one team is asking, is it possible to detect the effect of El Nino on the wind patterns?
So indeed, the El Nino gives you different wind patterns over the tropics or the Pacific tropic, or the tropical areas of the Pacific in particular. And the Aeolus mission will be able to measure these changes in the winds. So indeed, we will be able to see that when an El Nino is occurring.
Thank you. We don't have any questions from the teams, but I have one question for you, if I'm allowed, which would be about what are the upcoming missions at ESA regarding Earth observation.
So we have several missions in the pipeline. One which will be flying soon is one looking at clouds and radiation. And this is, of course, very important to know the role of clouds and also air particles called aerosols on climate and climate change. Another one is looking at the Earth's surface, at the biomass, which is trees and plants, and their role in the carbon cycle, which is also very important. And we also have some future candidate missions where some of them are sure to fly, some not. And these look into different areas such as ocean currents, polar areas, the changes in sea ice, etc. So there are many very exciting missions in the pipeline to be prepared.
Thank you.
Thanks very much, Fatima. So now we're going to highlight some moments of the project and show some of the great work that the climate detectives did. You all started your journey as climate detectives many months ago in October 2018. You identified important local problems and their relation to climate. Scientists were reading your investigation plans and gave you feedback. At this time, we would like to thank all of the scientists that were involved in this project. In January, the team started collecting data to investigate their local problems. In February, we organized a webinar with Dr. Natalie Douglas, in which she explained how scientists investigate climate, and she also gave some ideas and tips to the teams about what we can do to protect our planet's climate. 2 weeks ago, it was a very special day for 4 climate detective teams. They had the chance to travel to Milan to the world's biggest conference on Earth observation, the Living Planet Symposium. They were the winners of the LPS 2019 Climate Detective School Award, and they had the chance to present their work at this conference to an audience of Earth observation experts. Let's take a look at a recap of this great day.
Contact with real scientists is very important for young pupils already, because when they see the scientists at work, they will find out that there is these possibilities for them in the future.
It was very interesting to study the vegetation on our own home island, and we have learned how to use different research methods.
I also learned to better understand the environment where we live, to respect it and preserve it.
Looks like a great day. So Annegret, have you attended this symposium, and why do you think that it's important for scientists to participate in conferences like this?
Yes, indeed. I was also at the Living Planet Symposium in Milan, and it was a fantastic event with more than 4,000 people from all over the world also attending this great conference. And we had scientists from so many disciplines within Earth observation, looking at the Earth's surface, ocean, and the atmosphere. And people came together to present the latest results from their research using the ESA mission observations. For instance, latest research in air pollution seen from the Sentinel-5B mission, or other recent results from other missions looking at the Earth's surface. And it was really great and important to get together and share this information in order to understand our environment and climate better and to progress.
Sounds like a really exciting event. So all of the scientists at the LPS were really impressed with the work of our students. We know that all of you have worked hard to analyze the data collected, try to get some conclusions, and to make a difference. Congratulations to all of the teams. Unfortunately, we cannot present all of the student projects right here, but we want to invite all teams and everyone watching to visit our platform where the student teams have shared their projects. The topics investigated range from air pollution, deforestation, acid rain, wildfires, and water resources to the investigation of extreme weather events. A few teams investigated air pollution. This is a topic that really concerns our detectives. Eco team Ana Aslan from Romania investigated the air quality in their hometown for 4 months, and they started a campaign called Together for a Cleaner Air. Within this campaign, they designed a questionnaire and found out that the people in their city considered that they are not sufficiently well informed about the air pollution in their hometown. Other teams also investigated this topic. These include Fortuna team from Romania, Talos team from Greece, Air Rescues team also from Romania, and Detectives do Clima from Portugal. And Grete, can you tell us a bit more about how we can investigate air pollution from space?
So investing air pollution from space gives you really the possibility to look in a much bigger scale to air pollution and what you can see in your hometown and when you do measurements. Measurements on ground are very important to see how the air quality is at the spot where you are and also in the surroundings. But with the satellite, you can look over the whole world. You can look into any country around the world, over the oceans, in remote areas, everywhere. So satellite measurements are really there to be able to follow air pollution and how it develops from day to day all over the globe, and it really gives you a global total picture on how air pollution is, how severe it is, and how it develops.
Thank you, Anne-Grete. The Detectives do Clima team that we have just highlighted is one of our youngest teams participating in the project, together with the following teams: Astronerds from Greece, Climate Agents, also from Greece, Climate Detective for Cantacuzini, Romania, and iLab Detectives from Italy. This team has a special and very important message. Please do not think that one single person's contribution is not making a difference. Congratulations to all of our young scientists. Now let's talk about some of our projects that looked at drought. The Climate Busters team investigated the problem of drought and the problems that occur from south winds in their hometown, Heracleion, in the island of Crete in Greece. Anne-Grete, could you explain to us how wind is related to climate?
So as we saw in the video about the Aeolus satellite at the start, winds are really created from temperature differences on the Earth. So the difference in temperature between the warm tropics and the polar areas, and that's again changed by the Earth rotation and also by the landscape. So if we are having a warming of the Earth and higher temperatures, and we're having a melting of the poles, etc., we get a different temperature distribution on the Earth, and that also leads to changes to the large-scale wind patterns, such as the jet stream that is going across Europe, and which is so decisive for the type of weather we have, whether we get rain or whether we have more dry periods. So really, to understand the link between climate change and how the local weather is changing, that's one of the biggest unknowns in climate research today. And we're trying to get behind that and understand how that link is in full detail to be able to say something about how weather changed in the future.
So some of our other teams also investigated the problem of drought and possible consequences of global warming, like wildfires and extreme weather events. The Rafina Space Team, one of the winners of the Living Planet Symposium Climate Detectives Award, did a study on the impact of wildfire on the 23rd of July 2018 on Rafina's local climate using satellite data provided by ESA. We also had 2 teams from Romania investigating tornadoes, the Climate Magicians and Tornadoes researchers. And Grete, do you think that more extreme weather events are going to become more frequent due to the changing climate?
That's a very good question. It's difficult to prove that, but what we have clearly seen of the past few years is that the amount of extreme weather events have actually been increasing. So, for instance, we've seen more hot days over the US and over Europe over the last years, really a clear increase in that. We've seen increasing periods of drought, and we've also seen increased events of very heavy rain, which is also what we believe is caused by climate change. So really, it's very important to look into these instances and understand that in full detail. And only by doing more measurements and improve our models, we will be able to predict more accurately into the future how these extreme events will develop, and also whether we will have, for instance, stronger and more severe hurricanes or other extreme weather phenomena in the future.
Thank you, Grete. Some teams investigated weather by doing their own measurements of air temperature and precipitation, and some teams investigated historical climate data. These teams are Diamond 502 from Romania, Da Vinci Climate Team from Italy, Small Researchers from Romania, 007 License to Change from Italy, Music Climatologists from Greece, Prometeo 2018 from Italy, and C1 Cataneo Space Center, also from Italy. And Grete, this is a recurrent question, but we think that it's very important. Could you explain to us the difference between weather and climate?
So weather and climate are quite interlinked, but you can think of it like this. Whether it's what's happening on a day-to-day basis within the next few days or the next week. When we talk about climate and climate change, that's how the average weather is changing on a timescale of 30 years or longer. So that means, are the summers, for instance, getting generally drier or wetter? Are we getting higher temperatures? And is the local climate and weather changing to give us a different type of environment? And this is more what climate prediction is about, to predict the average weather and temperature and precipitation into the future.
Thank you for this clarification. Before we check with Fatima if teams have any more questions for you, we would like to highlight a few more projects. The Ciencia C4 from Spain explored the influence of a thermal power plant and a waste management plant on the landscape and in the climate of their region. 2 teams focused their investigation on trees, their relevance to the climate, and the topic of deforestation. These are Parco observers from Germany and Detectives Waldorf from Romania. The EHAN team from Italy investigated mountains and glaciers as sentinels of climate change. They have done their project in collaboration with research institutions and universities from their region. We have highlighted here some of the projects that the team shared in the Climate Detectives platform. We know that more teams will share or have shared their projects. Unfortunately, we could not show all of them, but we are really impressed with what all of the teams have done. If you want to see more projects, visit our website at www.climatedetectives.esa.int, as more projects will still be published. We're getting close to the end of this event, but we still have one surprise for you. Before that, and before we conclude, let's check with Fatima if the teams have any more questions. Fatima?
Yes, so we have here some curious teams. So we have 3 questions. The first one is also related with El Niño. And the question is, what effect will climate change have on the El Niño?
That's a very good question, and I don't think that the scientists know that really in full detail today. That's one of the big research topics. What they have seen, though, and what they are predicting is that we probably will have more frequent El Niños in a changing climate. This is what they expect, but it's really a topic for research where a lot of scientists are looking into this.
Very interesting. Perhaps our scientists, our young scientists will explore and discover more about that. So now we have one question from Team Promoteo. They are asking if can there be a relationship between an increase in rainfall and an increase in temperature? Can this relationship be influenced by the fact that you are close to the sea?
It's a very good question. So when you have rising temperatures, the atmosphere actually have more possibility to store water vapor. Because the temperatures go up, you can store more humidity. So we know that this also can cause more heavy rain events, but it's not only the fact that you have more humidity alone, it also has to do with things like air pollution and the triggering of cloud formation and other factors that triggers cloud formation, also including changes in the winds actually. So, but generally, we are expecting that the increasing temperatures and more humidity will give at least more heavy precipitation events.
Thank you. I think the next question, perhaps it's also similar, so we have two more questions. So this next one is, so we already know that the temperatures influences the type of rain. So if we have snow, if we have rain, but also influences the quantity, the amount of rain that we have. Is there a relation between the temperature and the amount of rain?
Well, the amount of rain also depends on where you have the low pressure systems. If you've heard about that or seen it on television, it's really these pressure systems where you get the cloud formations and the heavy rain which is formed on the so-called polar front, which is where along the path where the jet stream is flowing. And changes to that also will change where these low pressures form, how strong they are, and where they will travel. So whether we get more or less rain depends not only on the temperature, but also a lot on other factors such as how the large-scale wind systems are changing and also the cloud formation around that. So it's a very complicated question, but there is a clear relationship as well between, for sure.
Thank you. We have really good questions from our team. So the next one is about if it's possible to build something like a microstructure in space to change winds and also to avoid climate change.
Well, to change the winds, actually, I think the main factor there is really the weather itself and is the temperature. So I think to build something to change the winds, you can change the winds locally by putting up a big screen. You will change how the winds is flowing past that screen. But the general weather, you cannot change by a structure in space, I think. But what was the second part of the question?
To change winds and to avoid climate change.
Yes. So avoiding climate change, there we know that what really makes a difference is to emit less climate gases, greenhouse gases such as CO2 and methane. But also it's important that we have a clean environment. So really that's the big message, is to reduce emissions of these gases. And that also includes on how we do our agriculture activities, because we know that methane, for instance, also comes from food production and cows, etc. So it's really our human activities on Earth which will be important, and to change that to make sure that we can moderate or avoid that climate change will happen too much.
Yes, thank you for the message, also very important, that also depend on us. So we have just a final question now, also related once again with your work at ESA, and we have one team from Greece that they are asking which of the projects that you have been involved was the most challenging for you?
That must be the Aeolus mission, I believe. We started to build it back in the early 2000s. It took in total 17 years to get it ready because we are using lasers on board to measure the winds, actually, which is quite funky, but it was also very challenging. We're using lasers with UV energy that we are emitting into the earth and measuring the winds. So this was really, really challenging, but extremely exciting when we finally finished everything and everything was ready and we launched it into space. It was a great moment and a great relief to all of the hundreds of people who've been working to make this happen.
Thank you. Thank you also our teams for the nice questions.
Thank you, Fatima. And thank you, Grete, for being here today, helping us celebrate with our teams and also for inspiring them. Would you like to send a final message to our Climate Detectives teams?
Yes, I would thank you very much for having me on the show today. And I would just like to encourage all of you students or pupils all over Europe to keep on discovering, keep on working with science. We need good people in the future to keep on working with space observation satellites, but also to work on climate change. So please come as a young generation and help us work on these things.
Thank you very much. So it's now time to show a message to our climate detectives from a very special person, a person who has been to space and has had the chance to see our planet from a very unique perspective. Climate detectives, get ready to listen to a message just for you from ESA astronaut Tim Peake.
Hello Climate Detective teams, I'm European Space Agency astronaut Tim Peake. Today I'd like to send a big thank you to all of you for taking part in the Climate Detective School project and for what you've been doing to investigate and protect Earth's climate. When we astronauts are on the International Space Station, flying over 400 kilometers above Earth, we can see it from a unique perspective and we realise how beautiful and fragile our planet is. When we're in space, we dedicate some of our free time to taking pictures from the cupola, which is an observatory with a clear view of Earth. And from there, we can see the impacts of human activities and of climate change. And we realise the importance of taking care of our planet. I know that you've been investigating many important issues related with Earth's climate, wildfires, deforestation, and also global warming and its effects in your local communities. It's really great to see many teams working hard to make a difference and trying to tackle the problems of climate change. So congratulations to all the students and teachers that participated in the project, and I hope you'll all continue to make a difference to protect Earth's climate.
So we'd like to send a big thank you to Tim Peake for sending us that great message. Also, thank you again to Grete for joining us today. And ESA Education would also like to send a big congratulations to all of the teams for taking part in this project. Thank you for inspiring us. Goodbye to everyone, and remember, keep making a difference.